Great. Hello, everybody. This is Miss Pie, obviously. I am gone, sitting in a hospital, waiting on my husband to finish getting his surgery done. Don't worry, it's not an emergency. It's like a shoulder surgery. Anyway, so I hope you have fun today and get lots of stuff done. You are going to want to get this worksheet out. This is the second page of the packet that you got yesterday. And you also need your notes out. We'll be referring back to them quite a bit throughout today's lesson. And then in this, first let's look at this worksheet. This is the second page. All this top part, I want you to totally ignore this. Cross it out. We're not going to do anything with this. These were instructions. If you had a really old calculator, you would do this. Sometimes if you didn't have the sigma notation. But for this exercise, I'm more concerned about you guys knowing how to use your sigma notation than to do all the alternative stuff. So I'm going to just get rid of that part, and let's look at this part here. All right, what did I just get rid of? All right, there we go. Now it's gone. All right, so let's look at problem number 1. We want to do the sigma notation. If you cannot see it very clearly on your paper, I know the little subscripts down here are really hard to see. This should be n equals 1 here. This one has a 5 and an 8 and plus 5. Okay. Just a really quick review on how to get that on your calculator. Really quickly, we'll do it for A. Let's see. Here's your calculator. Remember your sigma notation. To get that, you click on this button with all the little weird boxes on it, and will be this sigma notation thing here. Okay, remember you need to put n in this box. Okay, you need to put the variable that we were using. We always start at 1. We end, in this case, for problem 1A, you're going to have a 5 there, and then you're just going to put the formula in there. So 8 n plus 5. Okay, then all you have to do is push enter. All right, so the total is 145 when you're adding up the first 5 terms. Let's look at B real quick. I don't feel like typing everything in the calculator in again, so I'm just going to highlight that, pull it down here, and then the only thing I'm changing from A, B, C, and D, the only thing that is going to change is your end value. So for B, it's going to be 15, and push enter. Okay? Do the same thing for C and D. Find those answers pretty quickly. It doesn't take a lot of time. And just write down the answers by the sigma notation. All right. So that's the first, I guess that's the second page of the packet. I'm going to give you guys about 5 minutes to finish the front of this page. And basically what I want you guys to do, work with your groups. If you have, let's see, 1, 2, 3, 4, 5. If you have 5 people in a group, I want everybody to pick 2 problems and do A, B, C, and D for both of those problems, and then share your answers with each other. So in other words, make sure that everybody in the group is doing a different problem. And so if you have 2 people doing the same problem, that's great, because in case anybody puts something in the calculator incorrectly, you'll have the wrong answer and you won't know that you have the wrong answer. So if you have 2 people doing it, you can check each other's work. All right? So you guys have about 5 minutes. I want you to have problems 2 through 6 done. I'm going to have the sub pause this video, and then they will start it in 5 minutes. Go. All right, hopefully you guys are back. Hopefully everyone has those problems done. Let's flip to the back. We're going to go through all of this back together. So items 4 and 5 shown below from the previous page have a special property that the other series do not have. What is it? Okay, the information is right there for you. Go ahead and read through it. I'll give you a minute to do so. Okay. All right, so for each sum, for each, the sums have a limit, or no matter how many terms you total up, the sum never increases past a certain amount. So for problem number 4, your limit is 4.5, and problem number 5, your limit is 7.2. Okay, next question. Look at the explicit formulas as well as the terms and the sequences for items 4 and 5 shown below. What do they have in common? So notice both formulas are in geometric sequence, or they're both exponential functions. And notice that hold on, there it is. Notice that your rate is a fraction. It's less than 1 for both of those. And on the terms, it's increasing, or sorry, not increasing, but you're decreasing every time, but you're never going to reach 0. Okay? Compare the explicit formulas and the sequence formulas for items 4 and 5 above with those of number 3 below. How is number 3 like the other two? How is it different? All right. So look at your rate. Notice that your rate is greater than 1, and you continue to increase with these. Hold on. All right, because your rate is greater than 1, the sequence terms are going to also keep increasing. Okay? And then the last one, compare the explicit formulas and the sequences for items 4 and 5 above with those in number 6 below. How is number 6 like the other two? How is it different? Okay, so most of you may want to say, hey, that's an arithmetic sequence, or hey, that's a geometric sequence. Well, that is actually an other sequence. You're not adding or by the same amount each time. You're not multiplying by the same amount each time. So this is an other sequence. Even though, yes, you are decreasing, your terms are decreasing, they're getting smaller and smaller and smaller, and you're never going to reach 0, but this is a other sequence, not geometric, okay? This is not a geometric sequence. All right, so why do we need to know about all this? Well, that brings us to our next worksheet and some of the notes. So get your notes out. I think this is on the back of the second page of your notes. You need to know this. So you need to know about the term that says converges. All right, so a sequence A sub n converges if the terms approach a limit as n approaches positive infinity. So as n is increasing, so let's say if I go all the way to the 100th term, I'm going to, instead of getting bigger and bigger and bigger, or smaller and smaller and smaller, I'm going to approach a limit. Okay, if not, we say that the sequence diverges. Okay, so you can either converge or diverge. If you approach a limit, you're converging. If you're going to just keep it getting bigger or smaller, then you're diverging. Okay, so then problems 1 through 4, write your terms in the sequence. See if you can figure out if you converge or not. And if so, if you do converge, what is the limit? Okay, I'm going to let you guys do those on your own. Next one, so please don't pause the video on this, just keep it playing. I want to go through all of these, get all their notes, and then they can have the rest of class time to work on this worksheet. All right, so now your series can also converge. If a series converges if the sums approach a limit such as x is approaching infinity. Where a series converges, it is often written as, I know on your worksheet that's maybe difficult to see. It's hard to see on the board here. So that's it's n equals 1 in the bottom, and then on the top you have the infinity symbol. Okay. So it doesn't matter what your formula is, but if you have the infinity symbol, that tells you that your series is going to converge. Okay, so how do you know if it's going to converge? Well, if you put, for your upper bound limit, if you put numbers that are getting bigger and bigger and bigger, but your total doesn't keep increasing, then that tells you that your series is going to converge. All right, so I want you guys to work on these problems, see which one of them converge and which does not. I want to know, does the sequence converge and does the series converge? All right. Last thing to put in your notes. If a series converges, then the sequence of its terms must also converge. So you won't have a case where your series is converging, but your sequence does not. Okay? But just because the terms converge, so just because your sequence will converge does not necessarily mean that the series will also converge. One type of series is easy to identify as convergent, and its sums can be found using a special formula. So the infinite geometric series. I'm giving you guys another formula today. Your infinite geometric series. An infinite geometric series in the form of, that's your sigma notation, converges when your rate is less than 1, and the sum of the infinite series can be found using this formula. So this is a formula you can use. Okay? So series sub infinity, because we want to know what is it converge to. A sub 1 divided by 1 minus the rate. Okay? This formula is much easier than all the other series formulas, your arithmetic and geometric, but you can only use this if your geometric series converges. Okay? All right. Hopefully by now you'll figure out that that's going to happen when your rate is a fraction or a decimal that's less than 1. Okay, so you have the rest of this class period to work on this worksheet. I am going to make it back up to school to do tutoring. I know I have several students that want to do tutoring. I need you guys to work on all the other problems on this packet and turn it in. Whether you are done with this packet or not, I want you to go ahead and turn it in. For tomorrow, when I look at it, I'm going to see how much work you did during class. If you were goofing off and not doing your work, then you're going to get points taken off of your grade. Okay? I will give these worksheets back to you to finish if you are not done. I will give them back in class Friday. All right. See you Friday, guys.